Now that you've learned what a derivative is and how to find a derivative using the difference quotient, we're now going to go through a lot of things that are really derivative rules that will help you to take derivatives much quicker. Okay, so we're going to start out with the most basic function you could have, a function that's just equal to a constant, just equal to a number. So for example, it could be something like f of x equals 3. So no matter what number you get in, you get out 3. Now first of all, let's just take a look at the graph. So if these were our x and our y coordinates, then this would be the graph of the horizontal line at y equals 3. Now, do you remember what derivative means? Derivative means slope, right? And for a straight line, the derivative is just the slope of that line. So remember, what is the slope of a horizontal line? Well, the slope is 0. So that means for any constant function, whenever you just have a number, the derivative of that is 0. Okay? Now, so that'll be a rule that you can just use. If you're asked to find the derivative of a number, you'll just say it's 0. Okay, but let's go through the proof. Let's go through the limit definition. You know, we know that f prime of x, the derivative, is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. Now this is actually a really simple proof, and sometimes it's so simple that it confuses students, but let's walk through it. So we're going to have this limit as h goes to 0. Well, f of x plus h means, what do you get when you plug in x plus h? Well, this function, no matter what you plug in, you just get out, we'll do it in general, our constant c. So f of x plus h is equal to c, minus f of x is equal to c all over h. Well, what's c minus c equal to? It's equal to 0. So here we have 0 over h, which is just 0. So we have the limit as h goes to 0 of 0, and that limit is just 0. We don't even have any h's. So that kind of gives our proof that the derivative of constant function is equal to 0. Okay, so mathematicians put a little box sometimes when they're done with the proof, so that's how we know we're done. So let's look at some examples. It says find the derivatives of the following functions. You don't need to do the difference quotient now anymore, now that you kind of know this theorem or know that this is true. So when we're asked what's the derivative of f of x equals 13, well, we can just say f prime of x is equal to 0. Well, negative, here we have our function f of x is equal to negative 24, derivative still 0. Okay, now this next one looks a little trickier. It's f of x equals pi squared plus the square root of e. Well, pi and e are just constants, which means if you square them and add the square root of one, that's still just a number. And you could put it in your calculator to get, you know, about what it is. But the whole point here is that this is still just a constant. It's just some number. So the derivative is equal to 0. So no matter what, if you have a function is just equal to a number, the derivative of just the number is equal to 0.